Hi guys, so today I'm going to go ahead and show you how to calculate molar mass of a compound. Excuse me. It's pretty easy, especially since we went over counting atoms last class period. So we're going to go ahead and start with sodium chloride. So I want to know what the mass of sodium chloride is. So the first thing you're going to do is we're going to list out our atoms. And if we remember, we went back to counting atoms, we need to go ahead and we need to say how many sodiums and how many chlorines we have here. So since we have no coefficient, we don't have to worry about that. All we need to do is we need to look at the subscripts that we have. Well, we have sodium has no subscript, so it'd be 1. Chlorine has no subscript, so it'd be 1. Then we need to take a look at the periodic table. On the periodic table over here, we're going to go and we are going to find the mass of sodium. So the mass of sodium is right here, 22.990. So we'll go back to our other page, and what we're going to do is we're going to multiply by the mass of sodium off the periodic table, which was 22.990. And then we're going to do the same thing for chlorine. Multiply by chlorine, go over to the periodic table. I find the mass of chlorine is right here, which is 35.453. We'll go back over here, and we'll do 35.453. So when we do that math, okay, 1 times anything is just that number, right? So 22.990 and 35.453. So now that we have the mass of each element, what we're going to go ahead and do is now we're going to take and we are going to add these together. And when we add them together, we are going to get, sorry, I gotta grab my calculator real quick. Because we don't want, I'm not going to have y'all round or anything like that. We're just going to do 22.990 plus 35.453, and we get 58.443. So the molar mass is 58.443 AMU, atomic mass units. And that's how you calculate the molar mass of sodium chloride. I'm going to do 2 more problems with you. So let me scroll down. And extend the page some. There we go. All right, so the next one that we're going to do is H3 PO4. So again, we are going to list out each element: hydrogen, phosphorus, and oxygen. And we have to say how many of them we have of each. So we have 3 hydrogens. Phosphorus has nothing behind it, so it's just 1. And then 4 oxygens. Now we're going to go ahead and we're going to multiply by their masses off the periodic table. So if I go back over here, and let me go ahead and erase the ones that we're not using. We're going to start with hydrogen, and hydrogen is at the very top. It has a mass of 1.008. So we'll go back and scroll down. We'll do a mass of 1.008. We'll do the same thing for phosphorus. So go back to phosphorus. And phosphorus is going to be right here. So 30.974. 30 0.974. And then I'm going to go back to the periodic table one more time. And we'll look at oxygen, which is 15.990. So 15.990. Go ahead, and we are going to do those calculations. We get 3.024, 30.974, and then 4 times 15.99, shouldn't be a 0, it should be 99, another 9, my bad. And we get 63.996. And we need to go ahead and we need to, oh, it didn't change on me. Take these, we're going to add them together. So 3.024 plus 30.974 plus 63.996, and we get 97.994. So 97.994 AMU. We're going to do one more. This time I'm not going to go back to my periodic table because I think I'll see what we're doing. And it's just kind of taking up a little bit of time. So I'm going to do one more problem. We're going to do calcium hydroxide. So list out our elements. List how many we have of each. Calcium, there's no subscript, so it's 1. Remember, the 2 gets distributed to everything inside of the parentheses, so we have 2 and 2. I will then multiply by the mass of calcium from the periodic table, which is 40.078. Oxygen is 31.998. And hydrogen is 2. I messed that up. Sorry, guys. I was looking at my math that I already did. This is 15.999. This is 1.008. I'm so sorry about that. We go ahead. We're going to do that math. You get 40.078. Now we get 31.998 and 2.016. We're going to go ahead, we're going to add these together. And we're going to get, let's see, get my calculator. 40.078 plus 31.998 plus 2.016. We get 74.092. 74.092 atomic mass units. Right. And that is how we calculate molar mass